hope you all made a choice of all the different pitches you heard, because now we are moving back to 2 streams. So you can scroll down on the web page. There's one stream of me, and I first go to the delivery Velo, and there's a second stream, which is Joost.
Yes, and we will go to the cable digging robot outside.
So, guys, are you ready to move? Now we split up, and I will go to the delivery Velo. Let's go.
Alright, so you're still hooked up, the cameraman is still hooked up, and we're going. Okay, we're underway. Welcome. It's in stream number 2, which is one of the nicest streams we have. And we're going to move outside now. Because our first demo is a robot that was developed for a power infrastructure company. And this, of course, power infrastructure requires a lot of cables. And if you put new cables into the ground, you have to do a lot of digging. And digging is hard work. So, that's why the firm that has given these guys an assignment have asked them to develop a robot that can take some of the heavy digging out of the hands of the professional workers that they have. But of course, the difficult thing about digging as a robot is you don't know where the cables are and where the cables are. And I think they've created some kind of inventive invention to solve the issue of knowing where the cable is. Okay, let's go.
Welcome, welcome. Be careful.
Hello.
Please be careful. It's very slippery.
Yes.
Welcome.
Well, tell us what the name of your team is and what your robot is going to show us, what your demo will be.
Yes, so this is Dirt, the cable excavating robot. First, I will point you towards our technician there who will demonstrate the mechanism and will also explain what it will do during that demo.
Yeah, so I will start the demonstration in a minute. Here in front of you, you can see the cable or the probing system of our robot. This probing system is designed
Down here.
to locate the cable by using a needle system. These needles will puncture into the ground, and when they hit an object, the computer will detect this and know there's an object or a cable there. We also have our digging arm here. This is a digging arm equipped with an excavator bucket. This one will scoop some dirt from the cable and bring it to one of our conveyor belts to bring it to the side of the trench. I will now start the demonstration.
So here you can see the probes probing the ground in order to detect if there are any objects. Currently there are no objects under the needles. Just now it will pass above this cable, probe the cable, and you will see that the needles won't go fully into the ground because there will be a cable in the way. This message will then be sent to the computer, and then the computer knows where to dig. In the background you can also see the movement of this robot. It can move in the X direction, it can move perpendicular to that, and it can rotate around the center axis. We will now go to the probing mechanism. As you see, it is now passing above the cable, where it will then probe the ground to detect the cable.
No cable.
This is how it should be. So it goes all the way into the ground. Now it goes above the cable, and you will see that the needle won't fully penetrate the ground. As you see, the needle doesn't go down all the way, and this indicates that there is an object there. If you look right there, that blocky screen in the back is a topology map. That is what the user would see and where the cable would be. Our technician Luke is now going to demonstrate the digging mechanism. If you would please focus on that.
Yeah, so the digging mechanism, it consists of an excavator bucket which will close itself and take a scoop of dirt. It has sensors in it to detect if there's a stone that it grabs, so it doesn't destroy the bucket when it closes itself.
Usually the bucket would close in this situation, but apparently there's a small technical issue that it will not close. We will try again later, and in the meantime I will entertain you with more information on our robot. So our robot, actually, for fun facts, it contains half a kilometer of wiring, 28 actuators, and a lot of electronics. We have a main computer, and then we have a lot of smaller computers. Back in the background there, to the left, there is a screen that displays our safety feature, the LiDAR. This is to detect where the robot is and if there are people to the left. The red dots there display an object in the way, and that the LiDAR detects that. On the background we also have some footage of the robot excavating, or what it should look like. Our technician now is going to move the digging.
To do the digging again. If he wants to go.
Yeah.
So just to clarify for the viewers,
Yes.
the process of what this robot would do, right? It would, if it arrives at a spot where usually the men are digging,
Yes.
or women.
Yes.
First the robot is probing
Yes.
where the cable is,
Yes.
and then it's sending out its second feature
Yes.
that is going to scoop.
Yeah,
Right?
that's exactly right.
Okay.
So usually you would have a worker on site, basically with a shovel probing the ground, doing exactly what we are doing, but then in a non-automated way. This we then implemented on our robot in a automated way, of course, and that sends signals to the machine, and then we know where not to dig, where the cable is, to avoid excavating damage. I'm gonna look at my technician.
We're not gonna be able to dig today.
Okay, we are not gonna be able to dig today, but if you look in the background, this is what it should look like.
Excellent. Fallback option. Very good.
So it goes down all the way, and then it closes the bucket with dirt in between.
Yeah, the bucket is reinforced with a steel plate in order to not break with hard objects.
This
I
was
see.
a very early prototype, so there were still some kinks in the program, but this is how it should look right now.
Okay, so and this was basically your demo, right? This
Yes,
was your
this,
demo.
this was the demo.
So what were you delighted about with this particular demo? What went well?
Yeah, so we are extremely satisfied with our probing mechanism. It is a very good technology, and it is going to be very useful in this field.
Mm-hmm.
In future, it would be implemented in a much smaller robot, possibly, that could drive over the ground by itself, and then you have two robots that communicate with each other.
And was there something that you particularly liked about this demo? I know one thing didn't work, but what was what went well?
As you could see, the buckets or the excavators on the side, they take the dirt and they took some dirt. There was already some dirt on the tile. They're not moving right now, but they are really functional when there's dirt on them, and they will take it all the way to the side. The angle of these conveyor belts is exactly so that an 80 centimeter deep trench can exactly be moved to the side, because you have an angle, or you have a hope of dirt will eventually be there, and that's the angle of the conveyor belt is exactly right. We also have some LEDs in the robot itself. These LEDs are there for the robot to also function at night, and that the workers have a good vision of what's going on inside the robot.
Okay, great. And some people could not be with us here physically today, so it's just the two of you.
Yes.
But could you introduce people here on the screen?
Yes, of course. So this is our team. Everybody say hi.
Hello.
Hello.
So in the top left we have Dan. He's a computer science engineer. Then we move to, well, top right, that is Wouter. He is our industrial design engineer. Bottom left is Minne. He's also a mechanical engineer. And then we have Rahul, who is also a computer science engineer. Then we have Luc, who is an electrical engineer, and myself, I am a mechanical engineer.
Okay, so thank you very much, everybody who's over there on the screen, and you guys here as well.
Thank you
for
very
this
much.
fantastic demo. This was a demo by Dirt for project client Aliander. And if you particularly like this project, you can come back, of course, in the breakout sessions. You can come here and ask questions, and there will be a full free-flowing Q&A with
Yes.
the entire team. So,
Thank you very
thank
much.
you for now,
Have a
and
good day.
very well done. This was our first and I think our best.
Good.
until now.
Okay.
Okay,
Good.
yeah,
Thank
thank
you.
you.
Bye bye.
Bye.
Okay, so what's your step here? Okay, so yeah, I think they were not only very good technical engineers, but I think the sales process also went very well. I think especially our man in the red overall was very good in explaining to you how this robot could work. One thing that bothers me a little bit about this robot still is how is it going to get to where it needs to be? Is it going to drive there? We don't know. So now on to the second demo. Their project title is "Can a Robot Build a Bike?" Wiping our shoes. Okay, so there you are.
Hi.
How's it going?
Good.
Good.
Should I take my mask?
Yes. Take off your mouth masks and.
Okay.
So tell us what the name of your project is and what you're going to show us in this particular demo.
Yeah, sure. So the name of our project is Bikebotics. This is the bike building assistant. And during this presentation, we're going to show you how we're going to help factory workers relieve the work strain and really help them in the factory and show our collaborative robots. Yeah.
So what is this robot going to do? What are we going to see in a couple of seconds?
Yeah, so first of all, we have the bicycle here. And just to give you an idea of how it would normally go, is you would have the factory worker here. It comes in from one assembly line. And you would have to grab it like this. And then move it over to this side. So you can already see it's like quite a heavy bike. So of course, what you would want is that they didn't have to carry this hundreds of times per day. So what we did, we found our own robotic solution to help them carry this bicycle, and that's what you can see here. So here we have the robot itself, and here we have simulated a bicycle with some weights that will grip. So as you can see, we can put the grip into the gripper like this, and it's sturdy, I think. So what will happen now is it will grab the bicycle and carry it up. This way we can get it out and move it around. So the idea is that as soon as this is done, it will retract the arm, turn it around and place it over on this side. Now we have some control panels that will help the factory workers with controlling the robot in case something goes wrong. But as you can see now, it automatically goes inwards, ready to rotate. Then down here, you can see some safety sensors. In case it moves and you're in the way, we have a camera and a LiDAR, and those are able to detect where you are, and in case you're in the way, it will actually stop the robot so you don't hit it. So by now you see that the robot is on the other side, and it will extend outwards again. So it's coming this way, a bit up, Jeffrey. Yeah, it's going a bit up. So now you have in this side. Of course, positioning it is very difficult. So what we did is we said there should be some control for the human to help. So to truly make it a collaborative robot, we made sure that they can also control it a bit. So what you can see here is that I can now grab the robot, I can position it precisely above the hole, and then now I can lower it. And as you can see, I can, for instance, control it with this control panel as well. I can lower the robot and it will safely go into the hole. After this is done, of course, it will go back again, turn around, and then it will start over. So yeah, that's the demo.
And so every time, of course, that you do a demo, something it's different, right?
Yeah.
So what was particular about this particular demonstration? Did you notice something that that you learned anything from?
From the last demo?
Or this one that you just did?
From what we learned from this one is that yeah, you just have to be very particular about how you move it around. So it can go wrong here, for instance, and if it doesn't fit in the hole, it gets stuck. And it could be problematic. So of course, when you're controlling it, especially during a demo, you want to make sure that all of it happens safely, so that it doesn't go wrong. Yeah. And
how was it for you, this demo? Was there something that you particularly liked about it?
Yeah, mostly I liked that we managed to get everything work. The last couple of days we had a lot of trouble finishing everything, getting everything to work, and I'm just really proud that everything functions like it should.
Yeah.
So it actually worked.
It actually worked.
And what is this? What is this part of the...
Yeah, so we didn't get to show that much during the actual mission, but what you can see down here is actually a display that visualizes to the factory worker what is happening inside the robot, what it can see. So we have these two sensors, that's a camera sensor and a LiDAR sensor. So the camera is able to detect where a person is on the screen, which you'll be able to see down here as well. You see a little face. And with the LiDAR, it is able to see the distance all around it. So maybe if you can zoom in, you can see some of the red dots here. Those red dots show you where it basically hits a wall, for instance, so you can see the distance. Then it tries to put that person on the screen and say like, okay, I see a person here, so I have to be careful of that. Of course, above that, it also shows some faces, and those faces are there to really show you what the robot is thinking. Right now we're in a demo mode, so it shows crazy faces, but normally it would tell you things about like whether it's rotating, or whether it sees somebody, or whether you have to be careful, stuff like that. Yeah.
Okay, so your idea is really that it's a collaborative robot, and it has different elements in it, such as the sensing, but perhaps also such as the way you can manipulate it a little bit. That it can't work on its own, but it can work with the people in the factory.
Yeah.
So, talking about collaboration, do you want to introduce your team here? Because you're just the two most extroverted people, maybe. I don't know why you're here.
I'm actually pretty introverted, but still.
Okay, so can you introduce the team?
Yeah, of course. Yeah, we didn't do this alone. Jeffrey and I are both computer scientists, but we have a whole team, of course. It's an interdisciplinary minor. So you can see we made a great shell. We have some cool mechanics, the electronics to control the motors. So in the call here with us, we have Tanya on the left. She is the industrial designer, and she helped us make the shell and make the robot look pretty. On the right side you have Bas. He is our electrical engineer, and he did all the controlling the motors and all the cool stuff. And then on the bottom, perfectly, you have Eric in yellow. They're aerospace engineer and mechanical engineer, and they actually built the mechanics of the robot, making sure that all the actuation could happen. Yeah. And it could carry the weight of the bike, of course. Yeah.
Well, thank you for a fantastic demo, and I'm glad it actually worked, because I know you've been sweating on it.
Yeah, that's very stressful. Yeah, for sure.
And well, we're going to move on to the next one.
Yeah,
and again, for if you're interested in this particular project, you can go once there is a breakout session. You can go here and you can ask them all kinds of questions. So let's go and let's move on to the next one.
Bye bye. Thank you very much.
Bye bye. We still have 2 minutes. We still have 2 minutes left. We're a little bit ahead of schedule. That's good. So now we're going to go to TorsoDoc, which is a medical robot. We're 2 minutes ahead of schedule. So I'm going to see if they're ready. But I think they are. Are you guys ready? Okay. So,
Just a second.
So this already looks quite interesting. I see an arm.
Hello.
Hello, guys.
Hello.
Could you tell the camera, tell the audience what your project is about, but especially what we're going to see in this demo?
Yes. So our client, Dr. Elko Roner, is a cardiologist, and he has this complaint that medical robotics really focuses on doing surgeries that humans can't do. But what about the common medical procedures? In Netherlands especially, they have a lack of doctors, lack of medical professionals, and we want to solve this problem. And we solve this problem by allowing doctors to focus on their speciality and let the medium level medical procedures be performed by a robot. And that's exactly what we have here, Auxilia, a medical robot that's going to perform these medical procedures. And in our demo, we'll show a blood puncture, which will be performed by this end effector here, and a scissor task. And yeah.
So your assignment or problem was, how can we not develop a high-end robot that is just for the very difficult operations or procedures, but more a robot for the simple ones?
Yeah. So to get onto it immediately. So a nice thing about this robot is, so it's made to really be easy to operate. And here you see an arm, and it actually has fake veins, and you see that the smiley is on it. So what the arm is going to do now, we're going to start it. It will use its camera to triangulate the smiley by taking two pictures, just like a human can do it. So
Just as a note,
it takes one picture, and then it finds a smiley, and then it takes another picture, and it finds a smiley again. And what it can do now is, given these two pictures, it can now very precisely move the tip of its needle to go above the smiley.
yeah.
Oh,
Sorry,
yeah.
we forgot to remove the case.
Okay, well, normally the casing wasn't there.
Yeah.
And then you see that it obtains an angle for a venipuncture.
No worries, we can do that now. We just
Oh yeah, you still have the safety.
Yeah,
on.
so there's
right,
a
no,
small
that's
cap.
very good.
Yeah.
And importantly, this syringe is interchangeable. So as you know, in blood puncture, syringes are only one-time use. So this syringe is interchangeable. And if you're wondering what the smiley is to place on the patient's arm. When it's on the patient's arm, it
And
will
it's
puncture.
also because the patient is smiling.
Yeah.
Yeah.
Yeah. Okay, so once we're here, we're ready to do the actual puncture.
Yeah.
So it's gonna puncture the vein.
It does, and this. Yeah, so these are magazines that we're gonna collect. These are blood capsules that we're gonna collect once it punctures.
How many capsules is it collecting?
It will collect around 2, but yeah, wait a second. I think there is a problem. Well, 1 out of 1,000 times it has to happen.
Yeah, it's always
Yeah.
during the demo.
Yeah, but we're still collecting capsules. That's not a problem.
Excellent.
And we might be collecting blood also.
And how deep is it puncturing?
So for the fake arm, it's puncturing 2 centimeters, but that's because of fake arm. And as you can see, we do collect some kind of blood, not perfect. But if you really, you're welcome to join us in our breakout rooms. We are going to perform this procedure step by step, and we'll explain every detail, and we'll show you another puncture.
Great.
Now, we can move on to another thing. First, let the arm move back to its home position.
So it finished the venipuncture and it successfully captured vacuum tubes.
And captured some liquid.
Yeah,
Not a
actually
lot.
from the veins in the arm.
Now, what we're going to do is explain the USP of a product, which is the interchangeability. Basically, if you buy one of these robotic arms, you get multiple, and if you develop multiple end effectors that can do multiple medical procedures, you can basically just install them really easily. This arm is really easy to use. Jules, if you can help me a bit.
Yes.
Need to be careful.
So it's like, on the one hand, simple to detach and attach, but also very rigid in order to make the needle
Because you
predictable.
can see how
at the
heavy
end.
it is. And it can,
Can I?
yeah, of course. And it can hold it. So, not a problem.
So it's not that heavy? Do you?
No.
No, it's okay.
So
And-
we also,
But
Just-
before we continue, I just
Yeah.
had one question
yeah,
about these, what do you call them? Vials,
Yeah, capsules.
capsules.
yeah.
So are you sure that there was no liquid in the vials before you did the test?
Well, we tried to make it sure, maybe. But yeah, no, we're sure. We got 3 of them, so yeah.
And they went in empty.
Yeah,
Okay.
they got empty. But
Yeah.
yeah, again, we'll show you the complete procedure when you come to our breakout
good.
rooms.
Yes.
So this is another one, and this is the scissor end effector, and this is basically not meant to be used in hospitals, but this just shows concept that we can use multiple end effectors. So here we go.
Yeah.
Maybe Jules can run it.
So a really nice thing about this robot is also that it's collaborative, which means that you can move it manually. And this, so first off, we have the smiley to locate the place, but also medical assistants can use this mode in order to place it wherever they want. So for example, we want to cut here. So then you just place it, and if we press play again, you'll see that it cuts in a straight line. Maybe it will actually cut, but that's the question.
Yeah, I will definitely cut the paper.
Yeah, if it's small enough, it will cut it.
Yeah. Oh.
Yeah, but this is very tough paper.
Yeah.
Yeah. So this shows, it's really cool how it knows what to do based on what is attached. So we don't have to ever tell it okay, now do the cutting task. No, it knows it just because we attach it. It's like, oh, the scissor is attached.
Do you have another one of these add-ons?
Yeah, so in development phase, we had 3 months of time. So this is the maximum of any puncture end effector that can draw blood and a scissor. But this is the future scope. So we have had 3 months of time to work on this, and we have an end effector that can successfully do blood puncture and scissor. So imagine the potential when someone works on it for 2 years. You can develop, for me, I would develop an end effector that can stitch wounds. imagine the potential of it. You can go to places that don't have medical professionals, and for example, in a place where there are not many medical professionals, you just give your arm and the robot will already do the stitching. So that's the future potential and the concept we're excited about.
So just to understand it, if I'm ill and I'm in a place where there are no doctors around, you say that I might go to an empty room or to a building, and in the building there's this robot.
Yeah.
And then I will just put my arm there. Oh. And then it will draw blood for me, and then maybe it will also. Who will collect the blood?
Of course, by this I mean sometimes there's lack of medical professionals that you can't collect blood and you have to travel 100 kilometers to a hospital. If you have this arm, it can be stationed and only needs to be run by someone who just knows how to operate the arm and not a medical professional. So then you can collect the blood capsule. You can get your blood test done and then maybe go to a lab. So that's the point. The point of this robot is to perform medium-level medical procedures that help doctors focus on their specialty. One last thing is we'd like to introduce our team. This is our team. This is Orestes. He worked on the software with Jules. This is Annabelle. She was the industrial engineer of our group.
Hi guys.
This is Casper. He worked in the mechanical engineering with me. This is Anna. She was the electrical engineer of our group. This is Jules. He did all this magic with the stereo vision and the smiley, and I'm Yash. I worked on the mechanical also. So, yeah.
So congratulations on a fantastic concept and a fantastic demo. We still have some time. So what did you think of the demo? How did it go?
I think it went well, except we did not capture the blood as we wanted it to. But again, in the breakout session, we'll show you one more thing. If you have time, I can show you the safety features, because one might think, well, a robot and it can puncture me and it can be dangerous. But if you come with me, I can show you our safety features, which is one, this top gap. So if you see, the needle is locked now, so it won't happen, but the needle is this much and the length of this is this much. So if you think, oh, it might just go through my arm, it won't, because it's going to stop here. That's a stop gap.
It cannot go through your arm fully because of the stop, right? Yeah.
There's this sensor. This sensor is a flex sensor. This sensor, what it does, if you puncture the vein, that's the reading it collected. You can focus there. This is the reading. So when it touches the arm, it shows us that, okay, I'm touching an arm, and then this spike says, okay, I'm inside the vein. So we know when we're inside a vein, and as we can read the sensor and then stop. So it will never do damage to your vein. And of course, Jules has also some safety features for the path planning of the robot.
Yeah, so the robot uses actually very advanced collision avoidance. So as you can see here, like everything that the robot interacts with is actually accounted for by the purple object. So the robot will never hit an object. It already plans in advance to not hit anything. So it's actually very safe, and you can also stop the robot at any time if you think the thing is scary. So we can start it again like this. So it's gonna do the stereo vision again, but if we just press the red button, it's like, oh no, let's not do it this time, and it just moves back safely.
Yeah. So we've designed such an arm with considering all the safety features, which we think is paramount. Of course, people, their natural instinct is to not trust a robot to do operations on them. As you can see,
of course, but it's a first development step, right?
Yeah, and we have considered everything safety, and hopefully in the future we won't be doing it on plastic arms, but actual arms. We'll see. Thank you.
Then one question about working for doing a professional assignment for a professional customer. How was that? What did you learn from that?
We learned a lot, because especially we work in multidisciplinary teams. We're from different courses. Everything comes together, and this is an invaluable experience for all of us, because we get to learn so much. He's a software engineer, and all this I've never seen it, but I've learned it from him, and it's the same thing. And of course, our clients they gave us the freedom to do what we wanted to, and
those are the best clients.
Yeah. And we tried to do what they asked, and yes, it was. Hopefully, this system is researched on more in the future and implemented in the health sector. That's always been our aim with this project.
Okay, so This was the TorsoDoc. Thank you for a great presentation and a great demo. And we'll be moving on to our last demo, the BoxBot.
Thank you.
Thank you.
Thank you.
Thank you. Bye. Okay, so now to the BoxBot. I think it has something to do with boxes. Hello.
Definitely.
Hello. It is demo day,
Yeah.
so we're going to see a demo.
Yeah.
What is the demo going to be about?
Yeah, so the demo we are giving today is we're showing off our robot, which will, with this crane type robot, will pick up these stacks of cartons with this gripper, and these gripper units will pick them up from below, lift them, bring them to the conveyor belt, and then the conveyor belt will take them on. And that's actually the situation in the factory right now. Now manual labor is needed, so people are doing this manually, and our robot is a solution for that.
Okay, so and who are you? You are the two of you. You have, of course, the team. Maybe before we start, first quick introduction of the team.
Quick introduction, definitely. So we're a team of 6 guys, 2 mechanical engineers that are me and Rick, 2 computer scientists, Tim and Zhao, 1 industrial designer, which is Lucas over there, and then we have 1 electrical engineer, which is Niels over there. So that's our team, and of course this is a team effort. We are the 2 that are fortunate to be here, but it's definitely a team effort. We've been working very hard this past 5 months with the whole team.
Okay, so now show us.
Yeah,
what the
let's do
robot's
the
gonna
demo.
And maybe tell us what we need to pay attention to in particular.
Yeah, so our robot is designed to be an automatic solution for the manual lifting of the cartons. So we hope that we can do it with the least interference as possible, but maybe I have to step in sometimes to help the robot do its thing. So my Tim will now start the sequence. So we have to pay attention to the arm, which will be moving down entirely until a certain position, and then when it's ready, it will squeeze the cartons.
So and now is this? Do you think it will work, or
Yeah,
have
so
you kind of made
I have
changes?
to check. In the final design, this will all have to be done automatically with the sensors on this gripper. But now I have to step in and adjust these cartons a little bit because it's a prototype. And now I can tell Tim, well, I'm just gonna have a look. It's looking fine, so go ahead.
Go ahead, Tim.
Yeah, it worked. So now let's lift them up.
So you actually have to say that to the robot, let's lift it up?
No,
or-
eventually this will be a fully automatic system. So the robot will detect with these sensors where are the cartons. First the camera will give it an estimation, and then these sensors will precisely decide where are the cartons, and it has to be done fully automatically. For now, that's not, the prototype can't do that. So for now I kind of have to help the robot just a little bit. But it's looking good, so I think it's ready to move to the conveyor belt. Yeah, so our robot, maybe to say some stuff about it.
Yeah, say some stuff about it. Just say some stuff about it.
Just say some stuff. So the design we are really proud of. Lucas did a great job with the design. It's,
Who was that? Who was did the design?
Lucas, the bottom left.
So can we close in on Lucas?
So he did a great job with the interactive design. For example, the lighting on the back is now telling us that the machine is operating fully functional.
Here,
It's moving up and down.
I don't know. Yeah, okay, I see the
So instead of the normal lighting which you see on machines, it's like a traffic light. We've kind of did a different approach, and we can also see that on the control panel right here. We have the lighting which goes around, and we kind of did a different approach on the standard situation as it is in the factories. So as it is now, the cartons are properly aligned to the conveyor belt. So Tim can now lower them.
It's very quick.
Well, it's not that fast. We would like to move it faster. But for today, for the demo, we want to be safe. We don't want anything
unexpected to happen. So we're moving a bit slow today. Now I'm walking to the conveyor belt here, because just to give a quick demonstration, the gripper will open and then I will move the conveyor belt so the cartons can go on to the packaging machine.
No.
So that is opened. Now we can move up again.
So, but the opening, is that done by the operator here?
Now it is done by the operator. Eventually, all of this can be done automatically. For example, if this switch has been triggered, the machine knows, okay, I am at the conveyor belt, now we can open. So it is made to be automatically. And I can now put on the conveyor belt and the cartons will be taken away. Yeah, so that's it. I think now Tim is moving the machine to a new stack, so we can pick up different stacks. The nice thing about this design is actually it's really modular, so it can pick up cartons here, there, in around 360 degrees. It can pick stuff up. Also, if this machine could be implemented for other kind of cartons or packaging stuff, because this gripper is only attached with one pin, which we can remove and attach a new part. So it's a simplified version of a robotic arm, basically.
Okay, so you know the system really well, right?
Yeah.
So if you do a test with it,
Yeah.
what do you then pay attention to see if it works?
So for now, I'm really paying attention. Is it going properly to the right location? That's the most difficult.
And where's the
part.
right location? That is, you mean it should match the slits?
Yes. So on the side there are these sheet plates, and those go inside these little triangles. So it's very important for the machine that these sheets go inside the triangles. If not, it will not grab them properly. And actually we have a system to verify that. So if this switch is triggered, we know, okay, it's on the right position. So that's really important. So let's see what it's doing now. So now the servo is going to compensate for the angle. Yeah. So I have to step in here, unfortunately, and just move them a little bit. Okay. So eventually the idea is that these sensors will go to the edges of the cartons. You can go, Robin. And we'll do all this, what I'm doing, the adjusting, the gripper will do it automatically. Yeah.
So that will then the back pain of a lot of people who are doing this will probably diminish. Then.
Yes, right now 1/6 of the time an operator in the factory, the brewery, is lifting these cartons and putting them on the conveyor belt. And these cartons might seem light, but if you're lifting a stack for so many hours, eventually your back will start hurting. And the operators themselves requested to the factory, you can go, Tim. They requested to the factory, find a solution for us. So, and they asked us, they came to us, can you find a solution, a robotic solution for this? And that's what we did.
So if you put yourself in the shoes of an operator who works in the brewery floor in the factory every day, and he looks at this, or she looks at this system, what would her question be, the first question to you? Do you think? What do you think?
I think the operators would ask me if it's safe. You know, can we work in this environment and it's not going to hit me or something? Eventually, we now have these lines around the machine, but eventually we want to have a more in the factory. We want to have a more extensive system with light screens. That if they come close to the robot can go into a pass mode. Also, I think an operator would want to know, is this replacing stuff I do? But this is actually, the robot is designed to help the operator, so the operator might have to come in sometime. But the operators at the factory are very highly educated, so this task for them is It's not their skill.
It's
their
not very
skill level.
interesting. It's
no,
not very interesting to
no,
do.
they can do much more interesting stuff. Maintenance for the machines, thinking about how can we improve the overall workflow. So
So they would be interested in if it's safe,
yeah,
and if it is, what else?
if it is
Maybe
reliable.
if it's reliable, and probably also how many boxes it can do, right?
Yeah, can it keep up with us?
Yeah, can it do its job?
Yeah.
Basically.
At this speed, it might not it can't probably keep up with.
Not yet, no.
No, with the. But the advantage is this robot can be operating 24/7. It doesn't matter if it is at day, at night. It can work all the time. So it can be a little bit slower because it can be working all the time. So yeah, this is. I guess that's what I have to say about it. You have some questions, maybe.
Well, maybe something about the process.
Yeah.
We're now looking at the end result. You've been working on this for a couple of months.
Yeah.
And were there highlights, but maybe also interesting to talk about, was there a moment of crisis?
Definitely.
And what was it, and how did you resolve it?
This weekend and yesterday even we had some crisis. So the whole the up and down movement, which is now a little bit slow, it actually broke down yesterday. So we had to mend it and put all our effort in fixing it as fast as possible.
And which bit was that?
Yeah. So what is the moving the crane up and down? There's a 3D printed part inside here, and actually. We did not pay attention, the robot was going out of range and it broke. So there was too much tension on the belt, it went too high and then it broke. So we had to mend it, so there were definitely lows, but we did work really hard, as long as we could, until 9 o'clock unfortunately this week. But there were definitely lows in the process, but also we are very happy now that we can pick the cartons up automatically and show that for the demo day.
And in terms of the soft side of collaboration, this was a technical issue.
Yeah.
Did you also had to overcome like a collaborative issue between the team members, or maybe between you and the project client?
Yeah, so what I noticed, me personally, is that it's for a mechanical engineer, it's sometimes difficult to know what are the computer scientists up to, what are the possibilities, how are they on schedule, is everything going okay? So I think.
Why is that? Is it because they cannot speak normal language?
No. They are definitely capable of speaking, but we speak in a different language.
Right.
So we are talking more about what is structurally. You can see if it's there. If it's not there, then you're behind schedule. For a computer scientist, it's difficult to see how progression is going. So we learned this project that you should keep communicating every day, every week. How is stuff going? Can we reach our deadlines? So that's definitely something we learned.
I see you're nodding. Can you also? You haven't said anything, so can you explain too? What you were nodding? What were you nodding about?
Well, for example, sometimes we have some.
You can speak loud if you want.
Okay. So sometimes we have some difficulties understanding each other. So, for example, my colleague there, mechanical engineer, he wants to be able to continuously remember the position of the robot. But for the software engineer, that might be difficult, as we need to home the system sometimes. And sometimes that's hard to understand for mechanical engineer, whereas I sometimes find it difficult to understand why this thing just cannot hold 20 kilos in that arm. Why does it need that counterweight? And sometimes that's difficult for me.
Yeah. And have you thrown with stuff? Have you, in anger, have you thrown stuff
No,
at each
I
other?
have not yet thrown stuff at my colleagues, and they have also not yet thrown stuff at me. So I think that's a good sign. We did have our difficulties sometimes. My computer scientist colleague, for example, he went to China for 5 weeks for some personal business, which definitely made the process more difficult sometimes. Also because of the time zones. But also because of holidays and restrictions. So yes, there have been some challenges.
Well, thank you. Thank you very much for a very good demonstration.
Yeah, thank you.
Brilliant project. Was there one thing that your client said about this that you kind of remember? Because they speak a lot, of course, but maybe there was something that you remember.
Yeah, well, they want for us a proof of concept. So they want to see, is it feasible? This machine will probably not go directly in the factory, but they want to see, well, is there a solution somewhere which we can show has potential?
And does it have potential? Did they say anything about it?
We believe it has potential.
Yeah,
so
you believe it. Yeah.
Well, they have not. They are
Oh,
watching
they
right now.
Oh, they haven't even seen it.
No. So to the
Oh,
client,
no.
I hope you think our machine can be developed even further, which would be awesome. And we think personally that it has potential, and it is a difficult challenge. These stacks are not always the same orientation. So dealing with that is not easy, but we think we have found some solutions to deal with that. Yeah.
Do you want to say something to the client?
I think you'll be able to make this work.
Yeah.
Now, I think this has potential. There are some challenges to overcome, but they should be doable.
Yeah.
So, yes.
They should definitely look into this machine more, and yeah, we also are down to. So there are some stuff that we just didn't finish because of time, and it is unfortunate. We would love to just have a little bit more time to make it.
No, you don't
perfect.
have more time.
But
You don't have more time. This is it.
This is it. Yeah. Unfortunately.
Thank you.
Thanks.
Bye. And also for the viewers, we were just fixing a cable, but for the viewers, you can also go into the breakout sessions with this team and then ask more questions. Okay, let's move to the champagne moment. Is it this door? Yeah. It's this door. Right. Oh, asking the person who's not there, is it this door? Okay, so we are now moving to this wonderful table with bottles that many of you have already seen. And I think we have about 3 minutes left. And then there will be a nice toast to this terrific Demo Day 2021. Sorry? Are we? Oh, so yes. Okay. So there's time. You have a couple of minutes now to switch back to channel 1. So that's stream 1. You go up in the site that you're watching now. And thank you for joining me with these 3 or 4 demos. And have a wonderful demo day after this.